Here we have 4.2, dividing polynomials, the notes for day one. We are going to be dividing polynomials by using long division. So the first thing we're going to do is do a basic problem with just numbers so that we can remember how long division works. So if we have to take 3,854 divided by 3, we would take the 3, write it out in front of the divisor box. We would put 3,854 underneath. So here what we're asking ourselves is how many times does 3 go into 3? We're just going to start with the first number and see if that works. And so 3 goes into 3 once. We're going to put the 1 over there. And then we take that 1, multiply it by the 3. We end up with 3, and we're going to subtract. 3 minus 3 is 0. Then we bring down the 8, and now we ask how many times does 3 go into 8? In case you aren't sure, you could say, well, 8 divided by 3, you get 2.66666 repeating, or 2 and 2/3. So you know that 3 goes in at least 2 times. So you can put a 2 up here. And then 2 times 3 is 6, so you're going to put a 6 down here, and you're going to subtract again. 8 minus 6 is 2. You're going to bring down the next number, which is 5. And how many times does 3 go into 25? Well, that is 25 divided by 3, and that gives you 8 and a third. So you know 8, and 8 times 3 is 24, and 25 minus 24 is 1. Now there's no more numbers. So if we bring down 4, 3 goes into 14 4 times. That gives us 12. And then we subtract 14 minus 12 to get 2. Now there's no more numbers to bring down, and 3 does not go into 2, so 2 is our remainder. So we can write our answer as 1,284 with a remainder of 2, or we could say 1,284, and we could take that 2 and put it into a fraction over the 3, which was out in front of the division box. So 1,284 and 2/3. And that is your basic division, long division. Now let's look at dividing polynomials. Here I have an example where we have 2x squared plus 5x plus 3 divided by x. Well, if in this situation, because x is a monomial, we could actually just simplify this as a fraction. So I'm going to split this up into separate terms. So we get 2x squared over x plus 5x over x plus 3 over x. When I simplify 2x squared over x, it cancels out one of the x's. We're left with 2x. For the second term, we get 5x divided by x. The x's are going to cancel out. We get 5. And for the last term, 3 over x, there's nothing to cancel out, so it's left as a fraction. And we get 2x plus 5 plus 3x. And for that, we can simplify just like we did there. But I'm going to show you how we can divide that using long division so that we have an easier start to the understanding of long division than just jumping right in with a binomial or a trinomial. So if I'm going with long division and I'm going to ask myself, how many times does x go in to 2x squared? So to do that, I could say, well, 2x squared divided by x. If I cancel out one of the x's here, I get this x cancels out with one of them up there, and I get 2x. So that number is going to go up here. I'm going to write that above the 5x. So 2x. Now I'm going to take 2x times the 2x, and just showing my work here, I get 2x squared. So that's where I write 2x squared, and that's where that comes from, is multiplying 2x times x. So now I'm going to subtract. When I subtract, I'm going to get 0. Here I'm going to bring down 5x, and I'm going to ask myself, how many times does x go into 5x? Well, I could do 5x over x. I can simplify that. The x's cancel, and I'm left with 5. And that number goes up here as plus 5 because it was a positive 5. And now to figure out what I write under here, I take that 5 and multiply it by what's out in the front, which is just x. And when I do that, I get 5x. So right down underneath the 5x, I'm also going to write the 5x that I got from over there. And I'm going to subtract, and I get 0. Now I bring down this 3, and I ask myself, how many times does x go into 3? Well, it doesn't go into 3 at all. So 3 is my remainder. And so I could put plus 3 over x. And here you could see my answer is 2x plus 5 plus 3 over x, which was the same as what we got up above. And we used long division. Now, that was an oversimplified method of long division, but I wanted to show you that process. Now, the book is going to ask you to use a division algorithm to express your answer. And the division algorithm is going to take p of x and set that equal to d of x times q of x plus r of x. And you're probably asking, what the heck are all those? So p of x is the original polynomial. So p of x is the 2x squared plus 5x plus 3. My d of x is the divisor. It's the x, what you're dividing by. So that's x. The q of x is what I get up here. I should clarify that. It's the x, 2x plus 5 is the q of x. Okay, so that's over here. So q of x is 2x plus 5. And r of x is the remainder. So polynomial, divisor, quotient, remainder. And my remainder, it was 3. So that's 3. So when I go down here and I write my algorithm, I do my p of x, 2x squared plus 5x plus 3 equals d of x, which was the x, times q of x, which is the 2x plus 5. So far we have not included the remainder, and that remainder goes over here, added to the end, so plus 3. And there is our division algorithm. So moving on to an example. This is just like the first couple problems in your homework. It says to divide p of x by d of x, and they give you here's p of x, and then here's d of x. We're going to set that up as x minus 1 divided into x cubed plus 4x squared minus 6x plus 1. Once we divide, we're going to give our answer kind of with that fraction, but then we're also going to express it in that division algorithm. So here we've got a binomial. And what we want to do is we want to focus on just the x, and we're going to ask ourselves, how many times does x go into the x cubed here? So we take over here, go over x cubed over x, we simplify that down to x squared. So that x squared is going to go right here above the x squared spot. And then we're going to take that, we're going to multiply that by the divisor out here in the front. So x squared times x minus 1 is going to be distributed here. We get x cubed minus x squared. Okay, that is going to get written down here, x cubed minus x squared. And I'm going to put that in parentheses, and we're going to subtract. So when I subtract here, x cubed minus x cubed, I get 0. And 4x squared minus a negative x squared. So if I go over here, 4x squared minus a negative x squared the two negatives make a plus. So I'm going to be adding these because of the double negative. So 4x squared plus x squared is 5x squared. So down here I write 5x squared, and then I bring down the minus 6x. Now I ask, how many times does x go into 5x squared? I can go over here and do my work, 5x over x. I can simplify this, and the one x cancels out. I'm left with 5x. So that number is positive, so plus 5x over here. And I'm going to take 5x and multiply it by the x minus 1. And when I distribute, I get 5x squared minus 5x. So that's going to go down here, 5x squared minus 5x. We're going to put that in parentheses, and we're subtracting. 5x squared minus 5x squared obviously is 0. Negative 6x minus a negative 5x. Again, we have that double negative. So we're adding the 5x. So negative 6x plus 5x is negative 1x. We're going to bring down the 1. And now we ask, how many times does x go into negative 1x? So if I go over here to show my work, the x's cancel. I'm left with negative 1. That negative 1 is going to go up on the top. And I'm going to take negative 1, multiply it by the x minus 1 from the front of the division box. When I distribute, I get negative 1x plus 1. So I'm going to write negative 1x plus 1. When I subtract, you already see I just wrote down both numbers are exactly the same. So when I'm subtracting, these actually both zero out, and my remainder is 0. So I don't have to worry about writing a fraction out here with my remainder. So the answer for A is simply x squared plus 5x minus 1 with no remainder to write a fraction. For part B, for the division algorithm, that's P of x equals D of x times Q of x plus R of x. Okay, so P of x is our original polynomial, which is x cubed plus 4x squared minus 6x plus 1 equals our quotient, our divisor. The divisor is x minus 1. So I'm going to put that in parentheses, x minus 1. Our quotient was this x squared plus 5x plus 1 plus our remainder. Well, our remainder was 0, so we don't need to add anything over here. So x squared plus 5x plus 1, and then here's our division algorithm. Now let's look at this example. We are dividing 3x to the fourth minus 5x to the third minus 20x minus 5 divided by x squared plus x plus 3. And all it says is to divide, and there's no special instructions on how the answer should be written. One thing we need to recognize is that there's a missing x squared term. And so when we set this up, we're going to write in a 0x squared in the appropriate location. So when we write this in, we have x squared plus x plus 3 divided into 3x to the fourth minus 5x cubed plus 0x minus 20x minus 5. And again, we're going to focus on the x squared, and everything else just works out and works into the equation later. So we're going to take that 3x to the fourth. We're going to figure out how many times does x squared go into 3x to the fourth. Well, as you can see, two x's are going to cancel out to leave us with 3x squared. And that 3x squared is going to actually go, oh, that should be a squared right there, right over here. above the 0x squared. And so we're going to take that 3x squared, we're going to multiply it by x squared plus x plus 3. When we distribute, we get 3x to the fourth plus 3x cubed plus 9x squared. We'll write that over here, 3x to the fourth, 3x cubed plus 9x squared. And we are subtracting. So here we get our 0. Negative 5x cubed minus 3x cubed is negative 8x cubed. 0x squared minus the 9x squared is negative 9x squared. And now we bring down the negative 20x. So now, how many times does x squared go into negative 8x cubed? So let's take negative 8x cubed divided by x squared. You can cancel out 2 of the x's from the top and you get negative 8x. So that negative 8x is going to go right up here as minus 8x. And we're going to take negative 8x and multiply it by x squared plus x plus 3. When we distribute, we get negative 8x cubed minus 8x squared minus 24x. So we write in negative 8x cubed minus 8x squared minus 24x. And we're going to subtract. Here in the front, we get 0, subtracting the same value. Negative 9x squared minus a negative 8x squared, double negative, so we're adding. So negative 9x squared plus an 8x squared is negative 1x squared. Again, negative 20x minus a negative 24x. So double negative, we're adding, and we get positive 4x. Sorry. All right, and then we're going to take down this minus 5. And how many times does x squared go into negative 1x squared? Well, negative 1x squared over x squared. The x squareds cancel to leave negative 1. So we multiply negative 1 times the x squared plus x plus 3. And when we distribute, we get negative 1x squared minus x minus 3. So we write negative 1x squared minus x minus 3. Put that in parentheses to subtract. Here we end up with 0. 4x minus a negative x, double negative, so we're adding the x to get 5x. Negative 5 minus a negative 3, again a double negative, so we're adding 3 to negative 5 to get negative 2. X squared is not going to go into 5x because the exponent on 5x is smaller than x squared, so we know we're done. So this 5x here is our remainder, or r of x, depending on if we need to write it like that. And so it didn't ask us to write the division algorithm, so we can write 3x squared minus 8x plus the 5x minus 2 over the divisor, which was x squared plus x plus 3. And that is our final answer. And that does it for day 1.